In this lecture, we will look at these two examples. The first one is to find the exact value of cosine negative 195 in degrees. The second one is solve for theta. Theta must be in this range, and if sine theta equals cosine to theta plus 75 degrees. Let's look at the first one. Here is ask us to find exact value. So the approximate value for this one will not be accepted. Okay? Yeah, some of you may do like what? You say, if you have the calculator is in degree, here is in radian. If it is in degree, you hit enter, and then you go back to do second, quit. If you do cosine negative 195 close parenthesis, okay, you may input the degree there, you may not. Okay, it's going to be the same. You see, this is approximate value, will not be accepted. Okay, so you see, if you put negative 195 and then degree, angle, second angle, number one is degree, parenthesis, you hit enter, you get the same answer. Here is that in those two cases, you'll get approximate value, but that's not going to be accepted. Alright, so you want exact value. For the exact value, you first want to do is cosine negative 195 degrees. You don't like negative, so you want to do in two ways. You can solve this problem in many different ways, but here is my approach. Okay, I like to do is, I know if I add 360 degrees on that, they are still equal, because 360 degrees is one period. Okay, so 360 minus 195 is what? 360 minus 195 is 165. Okay, so it's 165 degrees. Okay, 165 degrees is the sum of what? Of 120 degrees plus 45 degrees. Yeah, those two are special angles, and we know the exact value for those two. Alright, now here is one angle plus another. Then you got to use the formula of the sum. For cosine, that will be cosine, here is plus, so you do minus, sine, okay. Then here is 120 degrees, you put right here. And here is 45 degrees. Again, here is 120 degrees. And here is 45 degrees. Okay? So the above equals that. Now, 120 degrees is which value? This one is the one you want to remember. Okay, so down here, let's say we have a triangle here. Here is 60 degrees. Here 60 degrees. then you know the supplement here will be 120 degrees. Okay, so cosine 120 degrees is actually what? If here is 60 degrees, you know here is 30 degrees, alright? Okay, 30 degrees. Then if this leg is 1, the hypotenuse will be what? Will be 2, huh? And then here the leg will be radical 3. Okay, because 1 squared plus radical 3 squared, that's 3. 1 plus 3 equals 2 squared, which is 4. Huh? So, you know, then you can recall the value for cosine 120 degrees. Cosine 120 degrees, you may consider the reference angle 60 degrees. Okay, that's what? That's 1 over 2, 1/2. But you know, cosine 120 degrees is in the second quadrant, and then that has to be negative. Okay, cosine 45 degrees, then we always remember is radical 2 over 2 minus sine 120 degrees. Sine 120 degrees, you know, the reference angle is 60, and that's what? Radical 3 over 2. Radical 3 over 2. Opposite what? Side over hypotenuse is sine. Okay? And then, you know, sine 120 degrees is in the second quadrant. In the second quadrant, sine 120 is positive, so here is correct. Radical 3 over 2. Sine 45 is always what? Radical 2 over 2. Okay, and then down here we have a 1 times radical 2 is radical 2. Okay, and then here radical 3 times radical 2 is radical 6, and then divided by 2. Okay, so that's the exact value. Does this value equals the approximate value? You can check, it will be equal to. You are done right here. This is what you wanted. Okay, but approximately this value should be equal to that, negative 0.9659. Okay, you may calculate to check if this is correct. So you see negative radical 2 is this one, minus radical 6 parentheses. That's the numerator, okay? And then if you divide this by what? By, oh, no, you see, it's better to check. 2 times 2, 2 times 2 denominator is 4, right? Yeah, I'm glad I checked. Okay. Yeah. So you see 1 times radical 2 is negative radical 2 minus radical 3 times radical 2 is radical 6. 2 times 2 denominator is 4. Okay. So if you divide numerator by 4, you then have a negative 0.965925. That's equal to the approximate value over there. Okay? So we are done with the first one. The second one looks hard, but is not. Okay? Remember, sine theta equals what? By cofunction, that concept, sine theta equals cosine 90 degrees minus theta. because this is the identity you're going to remember. Yeah, sine theta equals the cofunction cosine 90 degrees minus that. Okay, that's what you want to start with. And then here is cosine, here is cosine. So then those two has to be equal. This one has to be equal to this one. Okay, then what you have will be what? You may do is 2 theta plus 75 degrees equals 90 degrees minus theta. Okay, now both sides plus theta. Remember, plus theta means 1 theta. Okay, because 1 times theta is still theta. And then 2 theta, 1 theta together is 3 theta. Okay, plus 75 degrees equals 90 degrees, since those two positive negative are cancelled. Alright, now keep going. You then do is both sides minus 75 degrees. Okay, so you may then cancel positive negative. And then what do you get? You get left hand side is 3 theta. Those two are cancelled. Right hand side is 90 minus 75. So it's 15 degrees. Okay. And then divided by 3. So theta comes out, which is what? 5 degrees. And 5 degrees is indeed in 0 to 90 degrees. So here is the final solution. So for theta, you know, theta is then 5 degrees. Okay, yeah. So those two examples, I should write 2 here, 2 here, or 2 here. Those two examples, I think they are a little bit typical. Okay, so you may review this, and then I'll see you next time.